Hello, my dear students. How are you all? Today we are going to do a very interesting topic, that is acidity of carboxylic acids. So you should be able to master this topic because in every class you will come across this topic. And let us now once again go through the basics and then the final points. So for an acid to be acidic, the corresponding A negative ion should be stabilized. Then only this equilibrium will move towards forward direction. So for any acid to be acidic in nature, its conjugate base should be stabilized, either due to some could be inductive effect, or it could be resonance effect, or could be any type of effect. So any factor that makes the conjugate base more stable than the acid itself would make it more acidic. So here also, any acid would be a strong acid if its conjugate base is more stable than the acid itself. Now let us discuss acidity of carboxylic acids. Why carboxylic acids are more acidic? Because when you take carboxylic acid and dissolve it in water, it would give carboxylate ion and hydronium ion. This carboxylate ion is resonance stabilized because of delocalization of the negative charge. The negative charge on oxygen is shared by two oxygens on the carboxyl carbon, while in the parent carboxylic acid, due to resonance there occurs charge separation, so such a structure would contribute very little and won't make it much stable. So the carboxylate ion, we can say in a broader sense, it would be more stable than the carboxylic acid itself, making the carboxylic acid to be more acidic. Now let us see any factor which makes the carboxylate ion more stable would make the corresponding carboxylic acid more acidic. So now let's see what are the factors that affect acidity of carboxylic acid. Number one is inductive effect, and then the resonance effect, of course the hybridization and the steric hindrance. So one by one we will focus on all these topics. Now let us discuss inductive effect. As you know, inductive effect is of two types: electron withdrawing effect and electron donating effect. And there are groups which withdraw electron, they will be called as electron withdrawing groups or EWGs. And when the groups which donate electrons, they will be called as electron donating groups. And you all know that more is the electronegativity or the electron withdrawing effect, more will be the acidity. So fluoro, chloro, bromo and iodo, they have more electron withdrawing effect because of their higher electronegativities, and whenever they are present in the given carboxylic acid, they would make it more acidic. Right? So number two is, more is the number of these groups. If there are 2, 3 or 1 these electron withdrawing groups, they would obviously make it more acidic. So more the electron withdrawing effect, and more is the number of these electron withdrawing group, more would be the acidity, and vice versa, of course. Then the third thing is, as the electron withdrawing group moves away from the carboxyl carbon, its electron withdrawing effect will decrease, and so will it decrease its acidity. For example, if you take fluoro, the first one is fluoroacetic acid, chloroacetic acid, bromoacetic acid. And you know, fluorine, because of its high electronegativity, would withdraw electrons from the carboxylate carbon and making the OH bond weaker, and the release of H positive would be easier, making it more acidic, followed by chloroacetic acid and then the bromoacetic acid. Similarly, when number of these electron withdrawing groups increase, they would also have pronounced effect on the acidity of carboxylic acid. In number 1, which is trichloroacetic acid, would be more acidic than dichloroacetic acid, and then the chloroacetic acid. So explanation would be chloro group has an electron withdrawing group, because of which it withdraws electrons from the carboxylate group and hence from the OH group, making the release of H positive as easier and hence making it more acidic. So more is the number of electron withdrawing groups, more would be the acidity, hence making trichloroacetic acid to be more acidic than dichloro and then monochloro. And in the third, as the electron withdrawing group moves away from the carboxylic carbon, its electron withdrawal effect would also decrease, and hence its effect on acidity would also decrease. So here it would be 2-chloro. First thing is 2-chloro butanoic acid would be more acidic than 3-chloro-butanoic acid. Similarly, you can solve other examples also. And the reverse would be the effect on of electron donating groups like methyl, ethyl, etc. Now, to understand the effect of acidity, we should know another term, that is acidity constant. Now, whenever carboxylic acid is dissolved in water, the following equilibrium exists. This one. Right, we take water in excess, so that its change in concentration will be constant. So this makes another constant which is called as Ka. You are very well versed with this acidity constant, Ka. So thus Ka, the acidity constant of a given acid, is a measure of concentration of hydronium ion, or indirectly you can say concentration of H ions, and concentration of the given carboxylate ion or the anion generated by the carboxylic acid. Hence, mole will be the number of H ions or hydronium ions given by a given carboxylic acid. Mole will be the acidity. And these acidity values, they come in the range of 10 raised to power minus 4, 5. So to make it more simpler, we take another value, that is the pKa, which is negative logarithm of the Ka values. So we should remember that more is the Ka value, more would be the acidity, while lesser will be the pKa value, more will be the acidity of the given acid. So let us understand this from this given table. The pKa value determined at 25 degrees C for acetic acid would be 4.79, and for chloroacetic acid would be 2. So lesser the pKa, more will be the acidity. For dichloroacetic acid, it will be 1.25, and for trichloroacetic acid, it will be 0.65. Similarly, when you have electron releasing groups, for formic acid, the pKa will be 3.75, and for acetic acid, where you have CH3 group as an electron donating group, its pKa value would increase and hence acidity would decrease. And in propanoic acid, which has 2 carbons as electron donating, the electron this releasing effect would increase, and so would its pKa value would increase and its Ka value or the acidity would decrease. So this was all about inductive effect, plus I and minus I effect. Now next, electron donating groups like CH3, C2H5, etc., they decrease the acidity. So formic acid in this case would be more acidic than acetic acid, then propanoic acid, and then butanoic acid. Let us do now this question, which is most commonly asked. These acids have been numbered as 1, 2, 3, 4 and 5. They have different groups. In first group you have in first case the first compound you have it's acetic acid, and second is trichloroacetic acid. Third has a CH3 and Cl2. You try to solve it yourself and find out how the acidity of these carboxylic acid follows the order. Number 1 is least acidic, and number 2 is most acidic. You try and to solve these and find out the answers for this and ask me for your doubts if any. And in the next video we will discuss the second factor, that is the resonance. How resonance affects the stability of the acidity of carboxylic acids. Right? So see you in the next video. Stay connected. Bye bye for now. Bye bye for now. And one humble submission: if you like this channel, do consider subscribing.